On the topic of partial fractions, in calculus, we use them to help us calculate the integrals, to evaluate integrals. In the very first case, suppose we have the integral of function f of x, and we are taking the integral with respect to x. If f of x can be written as px divided by qx, and the degree of the denominator is more than the degree of the numerator. Degree of qx is more than the degree of p of x if q of x can be written as the distinct product of linear factors. Product of linear factors in distinct form. It means that if q of x can be written as a sub 1x plus b1 times a sub 2x plus b2 times the rest of the linear terms that are all distinct from each other, a sub kx plus b sub k, then the integral of f of x dx, which is the integral of px over qx dx, can be separated into the integral of a1 over a sub 1x plus b1 plus a sub 2 divided by a sub 2 of x plus b2 plus the rest of the terms, rest of the fractions in the middle, a sub k divided by a sub kx plus b sub k, and then you take the integral with respect to x. So this is the approach in using partial fractions, and please pay attention, this is case 1, when you can divide up the denominator into distinct cases, distinct linear terms. Let's go over a quick example. Suppose I ask you to evaluate the integral of x plus 5 divided by x squared plus x minus 2 dx. So first of all, please pay attention here. Your f of x is equal to x plus 5 divided by x squared plus x minus 2. The degree of the denominator, so this guy is your px divided by qx. The degree of the denominator is 2. The degree of x squared plus x minus 2 is 2, which is the highest power in your polynomial. And indeed, it is more than the degree of the numerator, which is x plus 5 or 1. Here you have invisible 1, and this is the degree of your numerator. So what's the meaning of that? It means that we cannot do any long division. So no long division here. Okay. Can I write x squared plus x minus 2 as the product of distinct linear factors? Let's try. X squared plus x minus 2 can be written as x minus 1 times x plus 2. These are distinct linear factors. It means that I'm following the very first case. This integral, the integral of x plus 5 divided by x squared plus x minus 2 dx can be written as the integral of a1 divided by x minus 1 plus a2 divided by x plus 2. Then we take the integral of each one of these with respect to x. Let me quickly show you how to find a1 and a2, and then we move on and take the integral using ln. So a1 multiplied by x plus 2 plus a2 times x minus 1 must be equal to x plus 5. The numerators must be equal to each other. So as you saw from the shortcut, if you set x equals to -2, you get 3 equals to a sub 1 times 0 plus a sub 2 times -3, and then a sub 2 is -1. If x is equal to 1, then 6 is equal to a1 times 3 plus a2 times 0. What's the meaning of that? It means that a1 is equal to 2. So this integral, the integral of x plus 5 divided by x squared plus x minus 2 dx can be written as the integral of a1, which is 2 divided by x minus 1 plus a2, which is -1, divided by x plus 2 dx. But remember that from calculus, we learned the integral of du divided by u is equal to ln of absolute value of u plus c. So the very first integral is 2 integral of du divided by u. When you take u to be x minus 1, du is dx. And you can write -1 in front of. Here you can use v. You can say that, hey, v is equal to x plus 2. dv is equal to dx. And you get dv divided by v. So this integral can be written as 2 times ln of absolute value of x minus 1 minus ln of absolute value of x plus 2 plus constant of integration. You can use algebra to simplify this further. From algebra, remember that. First of all, if you have k times ln of u, this is ln of u to power k. So if you have k in front of the ln, this k acts like an exponent for the quantity inside ln. So we can write the first quantity as ln of x minus 1 to power 2 minus, let's copy down the second ln. So now we have subtraction between two ln's. Again, from algebra, remember that if you have ln of a minus ln of b, this is basically ln of a divided by b. So this guy in terms can be written as ln of x minus 1 to power 2 divided by absolute value of x plus 2 plus constant of integration. Both of these answers are acceptable, everyone. So if you want to use a little bit of algebra and simplify this further, feel free to do that. Otherwise, we can leave it as it is.